Hi everyone, it's Mr. Baker here, and today we're going to be looking at pressure in fluids. Okay, so today we're going to be looking at pressure in fluids. We're going to be able to describe how fluids cause pressure, be able to describe how the depth of the fluid changes the pressure, and then be able to state the equation, and then maybe be able to even derive the equation for pressure in a fluid. Right, start off with then, let's think about what we know already about pressure. So if I was to ask you to describe the pressure involved in a balloon and to describe the pressure involved in a glass of water, I want you just to write down whatever comes in your mind, or just to think about what you would say. What's pressure got to do with how a balloon is? What's pressure got to do with a glass of water? Okay, just have a minute, maybe pause the video and just to think about it, and then we'll go through and look at that. Okay, so you might have said something like this for the balloon. So if you look at this diagram, first of all, you can see that we've got the atmospheric pressure, that's the particles in the atmosphere pushing against the outside of the balloon, and then we've got the particles inside the balloon, the air pressure inside the balloon pushing out. So the pressure is caused by the air particles colliding with the balloon in either way, either the outside or the inside. The air pressure inside is balanced with the atmospheric pressure from the air outside the balloon, and that's why it looks like that. So you might have said something like that. So we're really, if you think about what we're looking at particles, we're talking about how the forces are balanced, the pressure is balanced between the inside and the outside. So things like that you might have said. Okay, how about a glass of water then? So you might have said something like the pressure is caused by water particles colliding with the walls of the glass, depending on the weight of the water acting on the cross-sectional area at a point. So it depends on what depth of water we're looking at, to how much weight of the water there would be above that, and then to how much pressure there would be. And this is really what we're looking at today. The depth of the water changes the pressure. The deeper the water, the more weight, and so the greater the pressure. Now, don't worry if you didn't say anything like that. It's quite a detailed answer, and this is really what we're looking at in today's lesson. But these are the kinds of things that maybe you might have thought about when you're thinking about pressure inside liquids. Right, I'm going to show you 4 very physicsy kind of demonstrations, just some pictures really, of some things that you need to be able to describe. So I want you to really be able to describe these. So if you were asked what's happening in each of these demonstrations, you'd be able to describe it in terms of the particles, in terms of the pressure, what's going on. Okay, so that's what I really want you to think about when you're looking at each of these 4. So in this one then, if you had some kind of bottle, like a big 2-litre like Coke bottle or something like that, and you stuck a load of holes all in the same height somewhere towards the bottom, filled it up with water, and then held it up, you would see all these spouts of water coming out of it. Now what would happen is that all of these jets would be coming out the same distance, and that's because the pressure in a liquid is all to do with the depth of the water, or the depth of the fluid, and so the depth of the fluid above it would be the same, and so they'd be coming out at the same speed, they'd be going out the same distance. But as the water level goes down, then these jets of water, these spouts of water, come out less and less fast, and so they go less far because there's less weight of the water above them. And that's really what's demonstrated in this next demonstration here. So the same kind of thing, but apart from all of the holes being at the same height, you've got heights all different along the bottle. So the one at the top, because it's got less weight of water above it, comes out the slowest and goes not as far, and then that increases and increases until the one down the bottom, because it's got all of that weight of the water above it, comes out the fastest and so goes the furthest. Okay, and this is all to do with the fact that the pressure in a fluid is caused by the weight of the water. It's all to do with the depth of the fluid, and so the deeper the fluid, the higher the pressure that is felt. Now this kind of thing has been in a GCSE exam before, just described, just actually to draw the levels of where the water would be. So I think they gave 3 levels and say, right, where would the 4th level be? Now you might think that the pressure has got to do with the surface area, because we said that the pressure is to do with the force divided by the area, but actually the pressure in a liquid is to do with the depth. And so in this system here, if you've got if you pour some liquid in, they're all going to go to the same depth here, so they're all going to have the same height of liquid in, because the pressure in a fluid is all to do with the depth rather than the cross-sectional area or anything else. Okay, so all of these, although they're all different shapes and different surface areas and things like that, the height of these liquids is all the same, because the pressure in the fluid is all to do with the depth of the fluid. Okay, so the pressure is to do with the depth, but it's also to do with the density. So if you have a look here, if we were looking at what is the pressure across here, this level here, so we've got 2 points X and Y that are the same height, and this is called a U-bend here. But this side is filled with oil, this side is filled with water. You can say we don't need as much water here to cause the same pressure as we need oil, and that's because oil isn't as dense. And so because it isn't as dense, you need more of it to have the same weight. So we need a larger amount to cause the same weight, which causes the same pressure as we've got here. And so that's why if you have a U-bend filled, some of it with oil, the oil goes to a higher level than the water because it's less dense. Right, so again, if I was to ask you again then to describe the pressure involved in, say, a glass of water, what would you say? So pause the video again, see if you can do it off the top of your head. What would you say? Think about depth, think about particles, think about pressure. What would you write down? Just pause it. Okay, so this is what I said again. It's pretty much the same as what I said last time. The pressure is caused by the water particles colliding with the walls of the glass, depending on the weight of the water acting on the cross-sectional area of a point. The depth of the water changes the pressure. The deeper the water, the more weight, and so the greater the pressure. So we've said that pressure in a fluid is caused by the particles and the depth of those particles. And we've also mentioned that it's to do with density. And so we get this equation here for pressure in a fluid. Pressure, P, equals the height of the fluid times this rho, density, times gravity. So if you have a column of liquid of density rho, a height h, then the pressure will equal the height times the density times gravity. And you can see it's got nothing to do with the cross-section area, it's just to do with the height, the density and the gravity, and at a point that's what the pressure will be. Okay, so you don't necessarily need to be able to derive it, but if I go through how you derive it, how you get to that equation, you'll see that I'm not lying to you, maybe. So we know this is our equation for pressure. Pressure equals force divided by our area. Different heights have different pressures. The force is given by the weight of the fluid above the point divided by the area of the cross-section. We'll call it the area. So area of the cross-section we can just call area at that point. So we could write down that pressure equals the weight divided by the area. We also know that weight equals mass times gravity. So we could write down then that pressure is the mass times the gravity divided by the area. Okay, so we basically, like, if you just say pressure is force divided by area, but we're saying that force in this case is weight, and weight equals mass times gravity. So that's what we get to start off with. Okay, so that we've started to derive it, we've started to get some of those things there. Okay, so if we carry on then, the mass of the fluid depends on the density of the fluid and the volume of the fluid. So volume, we know, is height times the area. So the volume of anything is the height times the area of one of the sides, isn't it? And the mass of the fluid is the volume times the density. So density is mass divided by volume, and so mass equals volume times density. So this is just rearranging the equation for density that you'll have looked at before. So then the mass of the fluid is the volume, the height times the area, times the density. And so then if we put that back into the equation that we just had a minute ago, we get pressure equals the height times the area times the density times the gravity, and all of that is divided by area. Now area divided by area would just be 1, so we can simplify that equation to pressure equals height times density times gravity. Okay, so like I said, Don't worry, you don't need to be able to derive it, but I just went through it just to show you that it's real, and really it's just the same equation as pressure equals force divided by area, but we're just trying to then show if we've got these other things, we've got the density, and we've got the height, and we've got the gravity, then we can work out the pressure at a point from a fluid from those three things. Okay, so these are the kinds of questions that you need to be able to do. So just to demonstrate that you've understood something from this clip, maybe have a go at these questions. You could just pause it, and then I will show you in a second the answers. So maybe just pause it, say 5 minutes, have a go at doing the questions. What can you remember from the clip? And then just have a look at the answers to check what you've got. Okay, so here are the answers to all of those. Just check what you've written and see if you've got those ones. Okay, so this is what we've done today. We've looked at pressure in fluids. We've described how fluids cause pressure. And we've looked at the equation. We've even gone through the derivation as well. And then we've had a go at some questions. So well done. Thank you very much. I've been Mr. Baker. I'll see you next time.